Let us solve this equation here, but we need to first prove, and remember this is a triple angle identity, so we need to show that cos phi theta is equal to this. So let us use the compound angle 2 theta plus theta. Now this gives us cos 2 theta cos theta. Then when there is a plus, we take a difference, then sin 2 theta cos, no, sin theta. That is how we expand the compound angle for cos when you have a plus here. So now we need to just get rid of this double angle. So we know that cos 2 theta is equal to 2 cos squared theta minus 1, and we know that sin 2 theta is 2 sin theta cos theta. So we substitute here, so we are going to get cos theta then into 2 cos squared, substituting for this, it will be 2 cos squared theta minus 1, then minus, then this is going to be 2 sin squared theta cos theta. When you replace this with 2 sin theta cos theta, this sign will multiply with this sign, we get sin squared theta. And when you look at this, we are aiming at getting cos out. So we know that sin squared theta is the same as 1 minus cos squared theta from the Pythagorean identity. So let us now substitute for that. Let me first remove this bracket and I substitute for sin squared theta. This will give me 2 cos cubed theta minus cos theta, then minus 2, where I have a sin squared, I'm going to put 1 minus cos squared theta, then times cos theta. So this gives us 2 cos squared theta minus cos theta minus 2 cos theta, then plus, when you multiply negative 2 with this, then plus 2 cos cubed. And by the way, this is not squared, this is 2 cos cubed theta. Sorry about that. Okay, so now let us see. This is 2 cos cubed theta plus 2 cos cubed theta, so we get 4 cos cubed theta. Then you have a minus cos, a minus 2 cos, which is a minus 3 cos theta. Then it is shown, because that is what is required and we have done it. Now we have a part B, the nth part. So for the nth part, we are given an equation, but the nth means we have to start from here. I want you to observe that we have a 4 cos cubed theta minus a 3 cos theta, and now here we have a 4 x cubed minus 3 this equal to cos 3 theta. Now here I have a 4x cubed minus 3 x equal to, I'm going to just take this part the other side, root 3 over 3. So we're just comparing. When you see we have a 4 4 3 3 minus minus, but now equal sign, it implies that we can see that x can be replaced with a cos. So let x be equal to cos theta. When you do that, definitely we shall be getting this left hand side. And when you look at this, it implies that cos 3 theta will be equal to root 3 over 3. So we can look for theta from here, then we can find the 3 values of, by the way, this gives us 3 roots, so we shall stop at 3 angles when we are solving for this x. Let us now use, by comparing, this is going to be cos 3 theta equal to root 3 over 3, so our 3 theta will be equal to the cos inverse of root 3 over 3. So let us see what comes out. Root 3 over 3. This is 54.7. So we have 3 theta as 54.7 degrees. So this is for 3 theta. But remember, we are going to look for intervals where cos is positive. So we have here and here, and we shall only focus on the first 3 values of theta. So we have this, we have this, and we have we have this, we have this. So we have got 54.7 degrees as the first theta. Then we are going to have the second theta as 360 minus 54.7. Remember, this angle here is 54.7, and with this one 54.7 degrees. The another one is going to be 360 plus 54.7. 360 plus 54.7 degrees. Because now you have to move one cycle, then you add that. Another cycle, you add this. But now we shall stop at 3 values of theta. So let us see what we get when we take 360 minus 54.7. This gives us 305.3. Then 360 plus 54.7, we get 414.7. So now our theta will be equal to, we are going to divide this by 3. This gives us 138. Then 305.3 divided by 3, we get 101.8 degrees. These are degrees. And then 54.7 divided by 3, we get 18. 0.2 degrees. So we are going to stop on only 3 because we are solving a polynomial with 3 roots. There are so many angles which can satisfy the theta, but now we are going to stop on the first 3 roots here. So let us see now what we get. Remember that is theta, but we are interested in x. So we know that x is equal to cos theta. Let me create some space here. So x, we have theta as 18.2 degrees, 101.8 degrees, and 138 degrees. But our x is equal to cos theta, so x1 will be equal to cos 18.2, and x2, the second root, will be cos 101.8 degrees, and the third one is going to be cos 138 degrees. So let us find out. Cos 18.2, we get 0.9. Another root, we are going to have a cos of 101.8, which is negative 0.2, and finally 138, which is negative 0.7.